Okay, hello everyone, and welcome to this interview series at Archidiaries, which is titled as The Shades of Green. We started this series last Saturday with the interview of architect Sankalpa, and we had a very nice presentation from him. And in the end, we had some really interesting discussions and points that were made. And today, we are going to talk to somebody who is a very dear friend and also who is a mentor to me, mentor to a lot of students who are watching this, who are going to watch this, Professor Surya Kakani. Surya, welcome to this interview.
Morning, everybody. Morning. Thank you, Ayaz. Thank you for getting me here, and it'll be nice talking to you all. Look forward.
Yeah,
Great.
we are really looking forward to the presentation. And please allow me to introduce Professor Surya Kakani here. Professor Surya Kakani's practice at Kakani Associates explores architectural resolutions within a resource conscious framework. The practice mainstreams this concern through various building types of schools, hospitals, and public institutions, which has been published and acknowledged in various journals and conferences. It has also been his conscious endeavor to connect practice and academic pursuit, both informing each other. Professor Surya Kakani has also held the position of Deanship at Faculty of Architecture, CEPT University, Ahmedabad from 2017 to 2020. Uh, the format for this interview is going to be the same that we have decided, and we will, Professor Surya Kakani will give us a short presentation here, which will sort of set the tone for the discussions, and then we are open for the questions, and we are also open for the questions from the people who want to participate and who have some questions for Professor Surya Kakani. Before I hand over the presentation to Professor Surya Kakani, let me just read out the brief which sort of summarizes what Professor Surya is going to talk about. The interview, the talk is titled as Architecture of Material Pragmatism. Uh, is architecture the making of a clay pot, a brick, a tile, or is it the making of a house, a spice rack, a ship, or a playground? Do materials, masons, and contractors build buildings, or do architects build them? This interview explores the ideas of materials and making as centrally placed in the field of architecture. How do we build? And what worlds of materiality and making do we inhabit in our built environments? This sounds for a very interesting discussion and a presentation, and we are really looking forward to you, Professor Surya Kakani. Can we have your presentation, please?
Sure. Thank you for this lovely introduction. I've tried to, I'll share my screen and then I'll start the discussion, presentation, and then hopefully we'll have a nice chat after this. So, I've actually titled this talk as an architecture of material pragmatism from the point of view that lot or everything that we as architects do or we produce involves material. And, architecture gets described from the rational to the very poetic. Yet, as I say, its existential reality is its material self. And it is within this framework, I've organized the presentation in a way that we put some of our projects in the context of, in our times of resource consciousness over consumption. We believe that a critical discourse in architecture, which in its very conception embodies a material reality, is imperative. The idea of how material plays such an important role, and as much as we need to consume it to build what we build, how can we be conscious? And so one is formatted this presentation. So this is how we believe that now begin to see that material is a finite resource, and if it is our new god staring ominously at us, how can then architecture find new meanings? So it is in that sense, one has organized the presentation to look at reusing a building in which the building itself is material. So you have an old building, and how do you take that forward? Do you remove it and build new, or can the building itself be material for the next moves? Then the idea of reducing carbon footprint. So how do we look at materials that have less embodied energy? And the other idea is of recycling materials, where a lot of buildings are broken, whether we like it or not. The cities are expanding at the scale at which they are expanding. Earlier infrastructure or material of construction gets demolished, and do we use it for landfills? Is there ways in which we can rethink about reusing them? Similarly, when we look at social equity, construction methods that we actually have amongst us, amidst us, is there a way that we can actually harness those skills to look at material? And that's the whole idea, that again, skill can also play a large role in the way we relook at material. Do we get it industrially produced, which definitely has a value of its own in terms of certain efficiencies of scale, but there are at least 60 to 70% of construction that still could use skill which is embedded in our culture. So I'll start with the first one, which is talking about, every particular title I put together a couple of examples. So I'll look at these examples, explain these examples, and hopefully it will express some of the concerns that we've kind of tried to embody in the practice. So this is a project which is called the Venture Studio. It's in the Ahmedabad University. There was an old building in the university, a very classic old building in the sense that it is a modern classic in terms of 1950s building, load-bearing, large building. If you can see my mouse, this is the old building here. This is very close to CEPT University. This is the Ahmedabad University area. This is an old building. At the back of the building, there was a portion which is not being used, and Ahmedabad University wanted to set up what is called technically what we call incubation centers, and they called it Venture Studio. And we were asked to see if they could put this old building to use, and we kind of I have actually put this building. This is the first slide here that you see is the old plan, and how all what we did was we built a plinth around the building. We opened the other side. The building has an entrance from the opposite side, and we opened on the back, which is technically the back, which now becomes the front for this V-shaped building. So one part of the V is what we were given. And most of the work that was done was related to building the plinth, removing some old openings, rethinking the way the building then begins to connect with the outsides. A small canteen was added, and then in the later years, cafe was added, which is quite popular in these parts, called Venture Cafe. So we opened the old compound wall at the back and entered from the north side now. So this is the old photographs and the new photographs. So you can see the building behind the wall, and this wall was opened up, and this is the way the entrance was created into this building. The left side is basically the old shots, and the right side is the new shot. It's the same, more or less similar close up, a little close up on the right side. So there's a plinth that comes up, and a shade that comes up on top, which connects the upper floor. So because as you go forward, you'll realize that we've opened up the windows on top to look down into the lower floor. It's more like a veranda, and that becomes a double height connecting the two floors, which is useful in an institutional setup. A small entrance was created. A small chhaja was put up, which made a small entrance to the office. So this is the old building. Had a beautiful jali. This old building was done by the very famous architect of Ahmedabad, Atmaram Gajjar, who has to his credit some of the most beautiful buildings in the 1950s, one of the largest practices of Ahmedabad, and solid load-bearing buildings. They had a certain repose in the way they stood. Now all that we did to this jali was painted red, deep maroon, and it is on the west of the facade, and it has beautiful light on the inside. As we move forward, it had a typical chhaja that went around the windows, which we put a shade on the top, and we removed all the chhaja. We took advantage of the top chhaja and extended a shade, and on the plinth, so the upper floor windows were pulled down to the slab, and they could open up. This is on the court of it, which originally the court, now the back for this particular building. We raised the level of the ground to meet the court, to meet the corridor. So the corridor kind of extends. So the corridor doesn't become a linear space, but becomes a rectangle space that is useful. In winters, this is the space, this is the south side. So in winters, you'll find people sitting in this space to work. We made a small bamboo jali that cuts off from the other parts of the university for security. So this is what I was talking about earlier, the upper level windows, which kind of open out. This is actually on the lower level here on the right side. This shot is on the upper level. I'll go forward, you'll realize. What we've done is basically opened up the windows to become part of the veranda, part of the veranda that is created on the north side. And the old windows were reused. They are metal windows, which we reused and just put doors in that. So this is what is the inside shot of the room, and this is how it now looks. On the lower floor, it opens onto the veranda directly. You can access the veranda. On the upper floor, you can overlook the veranda. So there's a connection between the upper and the lower floors. This is how it was and how it is. The next is our own house, old house, about 1980, early 80s, late 70s. Housing board construction in Ahmedabad, basically parallel walls, simple a simple box, which we stayed for about 10 years, and we redid the house. It was in bad condition. We kind of strengthened it a little bit and rechanged the functions, reorganized the place. On our north side, we had IIM as neighbor. So we opened up the house onto the north. We made a court out of the compound wall. So basically the margins, which is a small 250 square plot, in which the margins take up quite a lot of space. So the margins ended up becoming our courts, which the house began to open into, as you can see here. And on the upper floor, we added one floor on top. On the second floor, where part of the half of the house is a terrace garden, vegetable garden. And on the second half of the garden, we've connected it into a rainwater and solar and stuff like that, which collects rainwater for us. For the last 10 years, we've been having rainwater for drinking and cooking. So this is, we removed all the old plaster, made lime plaster. We added a passive cooling system, basically a wind catcher on top with a wind tower, which opens into all the rooms. This is the drawing for that on the right side. This is also a small water plan. So although in this particular house, as much as we do rainwater harvesting, The washing machine water goes into a tank, which then gets recycled into all the flushing systems. And all the rain that falls on this plot, which is not used for rainwater harvesting, is there are pits in various corners of the plot which go into the ground. The idea is that more and more water needs to go into the groundwater, become part of the groundwater systems, rather than getting washed out. So this is the large. Even when we were curing the house, we found a simple system of, what we've traditionally seen is that they take a hose and you start watering. The whole place is filled with water, and a lot of water is wasted. So we put a small, the one that farmers use for farming in pesticides. We just put that. We filled water in that, and we could spray water. So with minimal water, we could actually cure. We can actually cure our walls, and a lot of water is saved in that manner. Similarly, a lot of our water from the basin goes into recharge of the soil, basically through leakage, through detail, which allows leaking pipes. This is how it is. We had couple of small water bodies, thick lime plaster, and this house used to have 3 air conditioners. Since last 10 years, we don't have air conditioners. We are pretty comfortable. Except during the peak humid season of about 15 to 20 days during the evenings, around 5, 7 o'clock to about 9, 10 o'clock. It's a little difficult because of high humidity, but those once you cross the 10, 15 days, the rest is life is great. These are very old photographs, so some of the plants and trees have really grown up now. So the lower floor is more like a veranda that opens up into the outsides. And this is the right on top. This is the duct I was talking of. Each of the rooms is connected into this passive duct that goes up beyond, and it opens into this. So you get fresh air into the rooms. This is the upper floor where the whole house is now lime plastered. All wood used is recycled. The whole idea was to see how far you can go in this. And we're quite happy with what we were able to achieve then. With minimum budgets. And this is the terrace garden where when we've been very active. Sometimes we are very active, sometimes due to paucity of time, we're not able to manage, but the times when we are able to manage, it grows very well. In fact, on the courtyard, on the ground floor, we have at least, we have a banana on a regular basis. Basically means that we have about 2 crops a year for banana. So yeah, so that's the house, which is basically about reusing the buildings. In an industry we did about 15 years ago, in our industry, we had a large span of 50 meters by 70 meters, where Himanshu Parikh was our structural engineer, Chaman Lal Gupta ji was our consultant for passive cooling. Himanshu actually helped us relook at structure in a very interesting way. He helped us looking at load bearing with fresh eyes and the possibility that what it can do. So this is a 50 meter by 70 meter span. In the outer edge, he was able to remove the columns and gave us walls. And because it had to be load bearing, we were able to turn the walls into ducts. And the whole outer skin of the factory basically became ducts that pushed fresh air into the building. And in the center was a court, we basically skylights with ventilation systems on top, which move the air through the building. We have a lot of things in this building, right from hollow block slabs to reduce concrete, to using thermocol waste, to reduce the weight of the thing, to fly ash, to rice husk on the roof terrace, reduce weight, to create slopes. There are a lot of experiments done on this building. Absolutely wonderful experience with the client. So these are all these various things, rice husk on the roof to create, because the 50 meter span, from 25 meters of span, when you have to remove rainwater towards the outer edge of the building, the slopes that you need on a flat slope are quite high. And we found that rice husk is a light material, and because of that material, we could actually reduce the strength in the concrete in terms of steel. And so once you, otherwise, engineers are prone to designing slabs keeping in mind waterproofing, and that also increases steel in the buildings. This is the span. This is the building with the columns. Just showing columns on the outer edge removed, and this becomes these are 32 peripheral columns removed. That's the plan. That's the construction that's happening of the building. We mixed. We needed about 15 to 16 lakhs. I remember about bricks. We used about 1 to 1.5 lakh red brick, and the rest is all fly ash. And we mixed it. The idea was to basically minimize our needs in terms of an aesthetic. So we said mixing up bricks and creating. So the red bricks are a little higher intensity at the bottom, and they reduce as they go up. And so it becomes a kind of a character of this building. And these are these hollow walls which allowed the ducts to come in. These are the hollow filler slabs, as technically called by structural engineers. Large blocks which we use fly ash and thermocol and cement as a fixer. When we started, we had to get this kind of thickness in the hollow block. By the time we finally decided the block, we were able to reduce the thickness of the block wall to about 1/2 inch. So give us a huge economy. This is how the blocks are kept, and this is how you get and you get a flat ceiling on the bottom. Now, the advantages of flat ceilings, you can see the kind of light that you get into the space. So all that, the idea was that we didn't use any lintels. The light reflects on the slab and moves quite deep in. You can see in this photograph here, and we were able to get a very nice lighted space, which is 25-meter deep to the center, and ambient light requirement reduced dramatically just by simple detailing of the openings. Deep set windows all the way to the top, roof to top, but deep set to save them from heat. So that's the sense of the space. That's the ducts that remove the air in the center. That's the kind of ambient light that one gets. It's an industry that produces fabric for Scandinavia. So they have task lighting very close to the tables so that you reduce your requirements in power. This is basically, we tried various experiments in that building. For misting, Chamanlalji was an amazing support. He's a physicist, and he helped us in figuring out how do we, what is the level of misting that one needs to do such that such that the air becomes cool and drops down and creates a default movement in the space, a current. And these are just examples of how actually old buildings in India actually used to do that long back. So it's not something that we've invented. It's just that we need to use it to the scales that we need to now use at industrial scales. This is one where we had done cylinders to fill up with water and then have the breeze go through. We had some problems. We found that they had fungus on these. So we did all these experiments for about over a period of couple of months. We used bricks. We used we used even terracotta. We used even Bangalore tiles. Finally, we ended up with bricks because Chamanlalji wanted a certain venturi to be created that would land into the duct and then push the air down. So this is drawings of that. These are various experiments. We were measuring the airflow with each of these types of experiments on the roof before we settled for the kind of system that went in. So this is the duct that goes in. The air falls because of getting misted. It loses temperature, and cold air tends to fall down into the duct, and each space has openings with lowers, and there are exhausts, whirlies, and physical electrical exhausts that move the air out to the center. That is a section of the duct. This is the center. This is the whirlies in the center and the ducts that allow the air in. Now we've actually got even the air outlets had to be increased. So exhausts have also been added. Electrical exhausts have been added on 2-3 ends of the duct to increase the air output. So this is the building. This is how the building looks. deep set windows, 3 slabs, 16 feet and 12 feet and 12 feet. A terrace, that's the parasol on the top that covers the duct. Then there is a school that we did in Rajkot. A very close friend of mine, Yashin Vibhakar from Rajkot, no longer in Rajkot now though, but we worked together on this project. And post earthquake, this school wanted, it was not about the earthquake. Actually, we had done a school in Ahmedabad which had done some bamboo work on it, and the client wanted to use bamboo initially. But then the earthquake happened, and then we started thinking, and we found that the client's cousin contractor was already using some waste in building compound walls, and the earthquake happened. And then we said, why can't we take this technology forward? Bamboo is a lightweight material, so it doesn't really have to, the walls don't need to be really going through a huge stress of load. So this is the large school. It's outside Rajkot, called the Wadi School, Galaxy system of schools. Basically supposed to be an extension campus where students would spend 2 weeks a year and just without books and do other things. But over a period of time now, they've converted into it became, I think sometimes the fallacy of success is that this has become now an international school. So it actually operates as a full-time school. So what we did was we actually got fly ash from the thermal industry. We got gypsum from Than, which is basically a ceramic industry. And we got lime from another Mithapur, Tata Chemical Factory, Mithapur. And that mix, along with some binding of cement, blocks were created and cast on site walls with the broken rubble. And those walls were built, and the bamboo, the metal was got from Alang. The pipes, the bamboo, it partly came from Dangs, and partly the tragedy is that most of bamboo, whether we like it or not, ends up coming from Assam and far off places. So some of the reasons why we have reduced certain kinds of bamboo. So when you want large, thick, hollow sections, they end up coming from far. Solid, small, thick sections are available in and around Gujarat. So one has to also imagine the kind of bamboo that one uses depending on the local area. So this is basically bamboo on top of the metal structure, covered with the mats of date palm, covered with thatch, which is a grass that is available in these parts. So that's how the school. I'm very sorry about this. This is about 2002 or 2003. So these are 18 to 17-year-old photographs. So please spare. I had some photographs, but I couldn't locate them, so I just settled with the old photographs. This is how it was basically a simple idea of a plinth and sunk. We just raised a plinth, cut fill, and the classrooms became. So the scale of the classes when you're walking on the plinth is very beautiful for the children to feel they can actually touch the roof. So these are trees have grown. This is now a large campus. All the recessed windows, courtyards. The idea of a large amphitheater with a huge banyan tree now. This is a banyan tree that has grown huge here and covers this whole amphitheater. So these are the idea of playing with scales became important because it was one module that we just repeated. It was actually a simple cut fill and a singular module, and the rest is all a play of scales. This is how the classrooms open into the courtyard before you step out onto the plinth. That's the corners opened up. Then over a period of time, we've also, I must mention, there's a very good friend who's actually been working since a long time. In fact, since the time we had also more or less started our practice 25 years ago. Keyur from Kesarjan, he runs an industry. He also passed out of the School of Engineering and Science, School of Building Sciences at CEP. And he actually started out on thinking about looking at waste as a potential building material. And this is a 25 years ago when nobody was thinking about that. So he started with fly ash, and we used his bricks right from the beginning. We were probably one of his first clients, and we continue to be working with him. He's great support he has been to us in our experiments. So once when we were working with lime, we were working with lime, and he looked at lime. He has actually done a lot of work with lime now, and is now available. He's now, what lime was not available. Now he's producing lime in bagged systems and sells it, which is otherwise a very complex process. And so this brick waste, he's actually converting it into bricks. He's done is these are the bricks that he produces at his factory. So various experiments were done. We've used it before, and then finally we were successful with him, and he was able to produce this brick for us. It has got basically waste brick. It has got lime, which is also from a waste industry, and also some fly ash and cement as a binder. And this is compressed and water cured brick. This is the office that we were building. So the idea is that a lot of building waste is generated, which can potentially simply become rehashed into new brick modules and reused again. So this is, and he uses a certain amount of clay, percentage of clay, to give it a certain color and binding of the edges. And it's all these are very small scale industry, and this is how the brick is produced. It has a very good compressive strength, and technicalities are all done. So this we basically decided that how do we use this brick, and we had already used this brick as an experiment in a paving in our house, and we saw about 6-7 years that nothing happened to it. We tested it, and finally we asked KU to produce this brick for us, and we said we should build a building in line, and we should build it 4 floors, because post earthquake, even for a 10 by 10 room, people were building 4 columns and the corners and concrete columns. And we said, no, let's build. And we've been building large, thanks to Himanshu Parikh, we've been actually building large load bearing buildings for 3 floors. So we said, let's do a lime building with 4 floors. We tried various experiments for horizontals, but we could not let go because of the earthquake issues. We did concrete slabs, horizontals, but the rest vertical, everything is lime in this building. In fact, the building that I'm sitting and speaking to you right now is that my office, our office. So this is also the idea of an architect and the architect's offices. And we said that, maybe today we are here practicing how do this. So as an architect, do I design a building that is so specific that if today it's not an architect's office, what happens to it later? Does it have to be demolished? Or can we as designers produce spaces that can be multifunctional? So today it's architects, tomorrow it's something else, the day after it's something else. I think is the role of a designer, that how can spaces become multifunctional? How can architecture address these needs as much as addressing all the other incumbent needs of the immediacies of program? So this was a simple 2-block building with a courtyard, which became amphitheater. So this is how it is organized. The gray bricks have been allowed to pop out by about 3 centimeters. So a simple, all the brick, this is lime mortar, no plasters. The idea was how bare minimum. So it's a basic bare naked building, as I would say. It's brick exposed inside, outside, no plasters anywhere, concrete as it is, floors as it is, no floors except in certain parts. We put wood on the steps, on the central parts. All wood used is sadar, which is basically an old solid wood, and used for basically support systems. We bought old wood and rehashed it. This is all the all bamboo. If you can see here, we've actually put jalis. Okay, I'll come back to that later. So this is a small amphitheater which goes down to the basement, and that's where the studio is, opens from outside, where we have our talks and other stuff that we share with the city. So this is all the bathrooms are with China mosaic, which is basically second-hand tiles that you break. And technically, you're supposed to have invest tiles, but people now you break old tiles and or second-hand tiles. And there is enough skill available in these parts to be able to do this. We used also a part of the bamboo as shuttering, so that you get a texture on the roof. All the old wood lower systems for ventilation. The office doesn't have any air conditioning, and so there's a ventilation system that's been worked out. The floor, concrete floor, directly we put cement and red oxide, and with 6 mm layer, we were able to just finish the flooring. We took extra care when we were casting the slab so that the levels are maintained well. And so we could save a huge amount of material. Otherwise, normally a floor you'd end up having about 0.75 quota and so many other materials that would come in to put again, whereas actually a good concrete floor can take can pretty much suffice the requirements. So this is the central space, the staircase. So this is what acts as the duct, where we've kept a cooler on top, a PDEC cooler, passive evaporative cooling, a cooler which actually throws air in down this system during the summer peak months, and it just floods the room and creates internal pressure and pushes the air out of the louvers at the bottom of the windows. The water is, again, a lot of systems have been done for the water. I'll not go through it again. The rainwater, wastewater, we've done all systems. There is the whole office has a solar on top, so it's basically we are in technical terms net zero. We do not have any bills to pay. Though we do get water from the municipal corporation, we put up a system that we reduce water outgo, and whatever we grow here uses the water. This is the thick most of Ahmedabad, Gujarat actually grows this lathi kind of bamboo, which grows in dangs, and we used all those kind of bamboo as jali on the outside of the facade. So that becomes, so it reduces, Ahmedabad has got a huge glare. I mean, the sun that we have in our parts, the tropics, is very strong. So we've used that as a jali on the outside along with the louvers for breeze and closing. So this is how the building looks. From the outside courtyard, the margins again become courtyard, the lower floor becomes a veranda. And this is how we use this space. So the idea was, how do we can we mainstream an end result as a credible contemporary alternative of a building type, which is easily adaptable to multifunction in the urban context. And as designers, we thought, along with looking at material and other things, could we also look at. So this is a lime building, 4 floors, basement plus 3, 5 years ago, done. The last and foremost, I hope I'm not overshooting time, Ayaz, please do let me know. This is the last part, which is basically looking at technologies of skill. And we started looking at horizontal spanning when we were doing the offices, and in fact, we couldn't really do much, and we were getting delayed in our office. We lost 4 or 5 years, and we finally ended up doing flat slabs, but we continued that. And finally, we figured that there are systems have been done traditionally in the country, in the world. And we came across these examples, and we looked at them in our own way and connected. And we used these systems in horizontal spanning. And I'll share that quickly with you. This is again the same thing. We use the same bricks that KUR produces for us. So skills, when we were talking of people as labor. So what kind of materials we use in the context of our economies. There's a huge skill, there's huge labor that's available. And it creates a whole economy and an experience that that allows you to connect into various levels of our society, which is this is an amazing person who was introduced to another colleague, and he comes from Bikaner, and he has an amazing sensibility in lime, and he taught us a lot about lime. various, we then mixed various herbs and various kinds of things. My partner Jai, she has always been a very good critique, uh, and we experimented with various uh, herbs to get those colors. This is just talking about skills again. All these kind of things are all possible because there are people who have the skills in this country. It is, and that's what one is trying to say here. All these things that I'm sharing here are possible because there are skills. This is skills that are there in our tradition. That means people love to connect to the built spaces. Are we in our own way able to find new ways of allowing, giving them that possibilities to connect into the new economy? And I think as architects we can play a huge role in harnessing these into the new economy. Simple things, very simple but beautiful skills. So this is a building. I'll quickly jump to the actual things here, the horizontal spanning that I want to share in this building. This is my partner runs an NGO, Jai, where she actually works with women in the villages and around surrounding villages, teaching them various skills for vocational skills for the living, economic skills. And then so we made these buildings where we're just about still getting there. They're under construction, nearly done. So this is what I'll share with you. First one is a Timbrel vault. A Timbrel vault is a system that Gustavino brothers have made popular, which is basically a Catalan system made popular by the Gustavino brothers in America. Yeah, funnily America, large spans, and then Oschendorf, John Oschendorf, a professor in MIT, he discovered them and he wrote a book about them, and a lot of this material is available in the books, and we have taken a lot of help from all these kind of various sources. There's amazing stuff on the net if one begins to search. And our intent was, how do we simplify this thing that every day it can become every day? And that was the struggle. And that's what I'd like to share with you in this one. We also discovered another friend of ours, Vikram, in Delhi, introduced us to masons in Rohtak who were actually doing these very flat shell domes. And we found, I went and visited, and I found that it's an amazing system which actually needed to be proliferated. So anyway, so now this is what it is. We did our experiments in our office. We failed a few times, a month or 2 months, and finally we cracked it. This is the vault in the office, a sample vault, and then we started off on site, a small vault, and then the large vault, and then finally the really big guy, 16 meters by about 5 meters, 4.7 meters wide shell. If you go back, you see these layers. This is how these layers come up. You can actually stand on top, and this is all done by hand by people and masons. And these are products that are not specially made. These are products that are available off the shelf. Any city is what is used for brick cladding. When people want to clad to make their houses look like brick, exposed brick, and these are half-inch, 10 mm thick tiles. Any Mangalore tile producing industry would be producing some of these kind of things. So, and these are again those bricks for load bearing, and we have ring beams for concrete, so we couldn't get lit. So my next enterprise, hopefully at some point in time, we remove concrete totally. In this one, we put concrete as tie beams to reduce thickness of the walls. One would, because of the stresses that the vault system or the dome system puts, thrust that it puts on the sides. And these are videos that I've sent. So this is the other one, which is the flat shell dome, which is what we call now. We kind of called it Rohtak dome because these people come from Rohtak, an amazing team of masons who, over a period of some chance, have picked up these skills and make this amazing. It is actually an art, I mean, poetry to be able to see them work. And as I'll show you some videos, you'll realize. And they can do this in such quick speed because it's an amazing thing. It's, I mean, there's one has to see them work to believe that this is real. And I actually spent a whole day because I also couldn't really believe. So I spent a whole day in Rohtak trying to figure them out. And I tell you, it was amazing. This is how it looks. And so we kept all our, as usual, the interior. This is the same brick that Kesergen produces for us. We've used in the flat shell dome. This is what it was. And as we go along, hopefully at some day we shall be able to some more interesting things. But the idea is to be able to, I think the larger key is really to be able to make things such they can be proliferated. The idea is not to be able to do innovation or do new things with materials such that they become boutique and they become potentially out of reach beyond people. We have to be able to make them every day and get them to become easy to replicate. And that's the only way some of these systems will proliferate. So I hope that we all can continue in this journey of innovating and making them a normative. So that's Ayaz. I think I'm done. So thank you so much. I will stop sharing my screen. Thank you, Ayaz.
Thank you so much, Surya. That was, I mean, it was quite a fascinating presentation, and the kind of a range of materials and technologies and the passive cooling systems and everything that you have been working with. It was quite an inspirational to see all of that, and many of the presentations that we have been visiting your office, but Many of the projects that you shared, I've been also seeing for the first time, and it was truly quite an inspirational. Now we have overshooted our 40 minutes limit, but if you're okay, then we can have a few
I'm okay.
questions.
I'm really sorry. I realized that. I think I was a little slow in the beginning. I went
No, no,
overboard
that
in
was
my.
absolutely fine. I mean, the presentation was too good. I mean, it is no point in stopping you in the middle. I have a few questions which I will
Please,
raise first, and then if we have someone from the social media, we can take those questions. I was
please.
just trying to understand the range of things that you have been working with, and it includes one, the alternative materials, the where you're trying to reduce the carbon footprints. It also includes the certain passive cooling systems that you have been experimenting with over a period of time. You have been also trying to see how the concrete, and there's a struggle that has been going on, and with each project that you have shared in this presentation, we can see that there is a next step taken, and there is till the you showed the last project in that Soch NGO building, where you are saying that only the ring beams are there of the concrete, and you are saying that in the next project I'm trying to get rid of that as well. So one can see that there is a constant, improvement in the knowledge base that is there in all these projects, and that has been very fascinating for me. And so when I look at all these things together, and I'm trying to understand the title that you have given, which is the material pragmatism, and it appears to me, correct me if I'm wrong, that it is not the material in the physical sense of the word material, but it is all those aspects put together that bring the materiality through which the architecture is realized. And
Very well.
that is what I think you're trying to talk about, because you're also talking about the skills, and you are talking about the processes through which the architecture is realized. So I would like to go with your first slide that you started, and you started in a very interesting with a very interesting quote that you said, and I would like to read out where you have said that uh, architecture gets described from the rational to the very poetic, yet its existential reality is its material self. So now we understood the material pragmatism part, which involves these technologies, which involves the decision through which architecture is materialized. Now, uh, so do you differentiate between the the part that describes the poetic and the rational versus the part which is, forms the material pragmatism? Is there a differentiation? Are there struggles between the two sometimes? What is your take on that?
Very, very, very lovely question. You see, in fact, that is what this is all about. The struggle for architecture has been that it has to be holistic. It also has to be evocative. You may have all concerns which may say that I'm using waste, I'm recycling, I'm reducing carbon footprint. How can you still do all that and make all that you do evocative, all that you do have a certain quality that you know that raises your experience of the place. And I think that has always been, because you, in fact, that is the struggle, because you are loath to using any excess, you are loath to wasting anything. As much as one wants to be frugal, one also has to aspire to create an experience that stays with you, that you want to come back to, that to be able to think about waste or think about recycling, think about carbon, think of all these things, doesn't have to be disassociated from being able to have joy in it. And I think for us, I think for as architects, I think that is our challenge, right? Now, you can do anything fancy today, because given technology, given away, resources of money and material and all that at certain level, uh, To me, it is, I find that doing the other kind of stuff actually easier. To me, this is the challenge. And to do, as much as we were the other day in the studio in our class, we were talking about less is more, and we discovered that me's is less is more. When you actually go deeper, has a huge problem. And and I think we need to understand this from this point of view, and that genuinely is less more. How much do you need? How much do you build? How much is there a way that the way you put openings, the way you connect materials, the way you connect the outsides to the insides, and the way you put the whole palette together? So yeah, so yes, definitely, this is the challenge. What you have actually said.
Yeah. So one needs to find a holistic, basically, approach in which these boundaries actually get blurred. And
Right.
when I was looking at, you started with the projects, and when you were coming towards the end, I was going through your studio in which you're currently sitting, and there are all kinds of things that have been tried. I mean, if I look at in terms of the material point of view, the walls are used with the recycled material, so they are recycled bricks that have been used. There is a lime mortar that have been used. Uh, there are bamboo screens in there. Then there is another layer which has the window, which again filters the light. I think in terms of language, there is a kind of a totality that has been achieved. And of course, there are other systems which are passive cooling systems and the rainwater harvesting system. So, and on top of that, you said that we are trying to work out a typology here, which is not only, which can become a kind of a let's say a meaningful approach for someone to look at it, right? Not only from the material point of view, but also from the typology point of view. So this project, isn't it, has managed to achieve the binding to the utmost possibility what we are trying to talk about, that zones.
Well, if you say so, yes, it is still a struggle. This we have been as usual. This is again an interesting question. When you're much younger, the idea of an architect's office resonates in your head. Is this, and we as architects, we all grow up in this whole idea of creating edifices of out of our studios in a certain way, and they become so important for us that we get so absorbed in the notion of our office that we are only thinking about it as us, and about, so in that way one went through all that. It took time, and then and I think this is where I was saying that my partner Jai, she really becomes a good sounding board or a critique, in the sense about, she always used to say that you architects can't think about anything but yourselves in terms of your buildings. And so, because it's this discussion when you're having on the office, and we're talking about, there are certain leeways that you want to take because you want it to have an architecture feeling, and then you get kind of, you get these breaks coming, like you're saying, and then you keep thinking, is it really about us? We're going to practice another 20 years, maybe 15 years. Maybe tomorrow it's no longer an architecture practice. Maybe something else can happen here. So then we started thinking, yes, buildings have a life much far beyond than all of us. And can they potentially, because they're using resources. So do we adapt to buildings and spaces, or buildings need to be adapted to us so specifically that they're redundant beyond that? So that kind of set the idea, thinking, into saying that, okay, today it's an architect's office, tomorrow it becomes maybe studio apartments, anything, and maybe a library. The idea is, how can it allow all that? So the idea was, these larger spaces are very straightforward and simple, and which can be used for multitasking, for using various. So this again is a design challenge, and I think this is a lot to do with us imagining ourselves in in our role as architects and people who build buildings, can we look beyond?
Yeah, definitely. I have another question. You in the project that you were talking about, the factory that you did a lot of experimentation with the wind catchers, and you mentioned a couple of people's names. And uh, when you're trying to work with these kind of alternative technologies, sometimes that are out of the codes, maybe you're trying and you're taking a risk. You are willing to take a risk as an architect, but you also need people who are around you, who are consultants, who are ready to take that kind
Absolutely.
of a risk. And
Absolutely.
what has been your experience? What kind of people you have been lucky to work with them?
I've been blessed, I would say. I've been really blessed in that context. And for structural engineering, we've had Himanshu Parikh for a long, long time. And all up, I mean, 80% of our buildings. He's retired, he's gone back to the UK. And he showed us how we could rethink uh, about a wall link system. You see, his simple logic was a 9-inch wall can take 2 floors, yet we put columns. Because also architects take a lot of liberty with walls. He says if architects are able to follow a certain discipline, then walls can do a lot more than they can even imagine. And in the same 9-inch wall, you can actually build 2 floors. In 1.5 brick, you can build 4 floors. All that you need to do is certain discipline you need to keep.
Yeah.
Now, the problem with us as architects is that we are loath to being told rules. So the problem is that we have to be able to play with the rules and yet create that quality that we all aspire for, to which is a never-ending game. And I think there we were able to find a great companion in taking our thoughts forward, whether it is horizontal slabbing, whether it is walls. So that was Himanshu. Then for passive cooling, we connected with Professor Chamanlal Gupta, an amazing soul, lives in Pondicherry, and he was amazingly patient with us. And he's a physicist and building physicist. Also the person who actually first chairperson, founder member of TERI, and he helped us. He is an amazing personality again. So sometimes along with all these things, you're also learning so many other things. Then we had Keyur, Kesarjan, ready to do an experiment for us, an amazing resource in material science. His knowledge on material and material science is fantastic. His own struggle to become an entrepreneur in alternative products is not something that everybody can do, and I don't think many have the guts to do. He has stood out, he has suffered, but he has continued. And it's an amazing thing that he's able to put various kinds of waste materials provided in various industries, and all he needs is some of us as architects to be able to, take those forward as products and give our inputs. So we also see, only when we use, we can give inputs. So when we were working with Lime, we started saying that, listen, Keyur, and I realized that Lime was not going to be able to beat cement any day, because cement is bagged. You can just go to the shop, buy it, pick it up when you want, how you want, and it is fast. In this country, lime was not available unless until you get a truck. You had to have a whole system of making a tank, put cement, slake it. I mean, complex. Right? So we started telling him, this is not going to work if we can actually bag it. He took it up. He went through a couple of years of research, finally he's bagged it. Today you can actually order lime bags from him. Similarly, producing bricks through waste lime and things like that. So he has that sense. So it's like people like that. Then people of skill. I mean, the number of various skills that are available around us. You have little patience. I'm telling you, there is people who will do wonders for you. It needs a little, cajoling, little pushing here, little pushing there, and little patience, and little bit of a heart to fail. And
Definitely. Some of the people that you mentioned, we also personally know them, and we have been following them very rigorously, and their journey in Silfar. So it's a kind, in that sense, it becomes a kind of a collaborative journey and a collaborative effort when you're trying to do, and you're not
absolutely.
just alone. I have some questions with me, but I would like to pause for a while and take some questions that people have posted
Sure.
on that. And one question that has somebody has raised last lecture when we were talking to Sankalpa, he started his presentation in a very, just like the way you started with the quote. He started with a diagram, and he said that our practice is a kind of a struggle. On one hand, there is an awareness in terms of an architect of certain environmental responsiveness. That the role that you need to play. You are aware of certain things, and but the client has, on the other hand, certain other expectations which come from, let's say, conventional thinking, and maybe many a times the clients are not willing to engage. So what is your approach in dealing with situations like that?
So yeah, absolutely true. And the clients obviously come from a certain experience of their own lives and the society that we have built, and they come back with those, and it's our job, and it takes time to be able to show them and take them on this journey. And I, again, as I said, I may have been, must be blessed. Some of my clients have understood me, or rather, I would say most of my clients, I would say, have understood what we want to do. Uh, in simple ways, is something like this. If you tell a client that a 9-inch wall or a 1.5 brick wall is going to reduce your air conditioning load dramatically, and you can still have your air conditioning, fine. You may not want passive, but if your loads are going to, what's the harm? And you don't need vertical steel if in these kind of buildings you can get large spans too. So, and I think we were able to build initially, and we are able to now share these examples with the newer clients, and the confidence is obviously different. So it's the first few clients who really have to have that confidence and trust, and as I said, that happened like in post earthquake. I remember in 2003 or 4 we did this school in satellite Anand Niketan, and we said everybody was building, and I told Himanshu, let's build load bearing large span and show that, because he had already told me that load bearing can do a lot. So I said, why don't we do this? And we did 18 meters by 16 meters spans, 3 floors, load bearing. We did 12 meters by 12 meters, that industry. We did this 50 meter by 70 meter. And those things happened. And this is just post-earthquake, because we realized that people had just lost trust on brick. The problem is, it is not the problem of the brick, it is the problem of the designers who use the brick. You open up corners, and you want these fancy, cutouts in certain scales. Certain spaces, okay, you can't do it. You need columns, you need metal columns, you need that. So I'm not against that. But I think it is the kind of weather and the climate and the place that you're operating in that finally needs to dictate these kind of things. And it may not be valid. This logic may not be valid everywhere. But in the space, so I think that's where the architects also need to be able to, be objective as to what decisions they make where, and not necessarily become a fundamentalist about one thing. So I don't want to become a fundamentalist about load bearing. I think it is about being objective, where you need lightness, where you need solid, where you need enclosures of some kind. So yeah, the clients have a huge role to play in this, and fundamentally, yes, I must tell you, this is very important. You have to be able to show that it saves you money somehow, and you can. And we found that brick buildings are far less cheaper than concrete buildings, and you are able to reduce your heat load in the building. Your diurnal changes in temperatures inside to outside are very less. So because of that, your internal loads are less, heat loads. So it works very well. And once they've seen it and then they experience it, then they are all okay with it, because a lot of buildings, people are also now becoming so used to enclosures, sealed enclosures, that they're not being able to, they're not being shown any other alternatives. And I think it's our role to be able to show that possibilities exist.
Yeah. So there is a role of an educator that you have to play with the clients as well. And you said it rightly. I was looking at the Madhu Industries project, and you said you've done it in like I think 15 years ago. But even if I look at the 15 years ago, the construction cost, you managed to achieve 550 rupees a square feet of cost of a construction with a fantastic quality and the sense of the material. And I think that is something that can really,
It was a
convince.
tendered project. The other thing I think I must also emphasize here is this was a tendered project. We tendered the project, which means as architects, our role in making sure our drawings, right to the T, each and everything is all clear to the contractor. So when you are actually putting your tender drawings, if you're putting your working drawings for tender, right to the finish on the top, your contractors will quote very tight because they know that each and every corner and detail. And when they see, so that's the other thing I must tell you, that this, in the walls, we didn't have lintels. So you had a slab. And then those contractors who understood this, we told them that you don't need to stop till the slab, till 16 feet. You don't need to stop. You just keep building the wall. What happens is when you have a column or a beam, you have to stop at lintel. Then again, the new agency, when a lintel comes in, you have to put shuttering, you have to get a steel guy, you have to cast the concrete, and then again you have to start the wall. So sometimes just understanding construction processes and setting up certain systems also helps in speed. The contractor is looking at speed because speed for him is efficiency is equal to cost. You are looking at so many other things in this. So in that sense, holistic also in every aspect. So the whole package needs to be thought through, and that's what our role is.
Yeah, there's another question from a very dear friend of mine, Sanjit Devnath, who is watching this. And my question is also quite similar to the timbrel vault system that you have been experimenting, the Catalan, this vault system. My question is, Prasanjit is asking us what are the type of mortars used in these timbrel vaulting systems?
It's a 1:3 mortar. The first layer. In fact, actually, we have put all the. I would also like to suggest we've put all this in public domain. We have put the making of this in public domain. If somebody is very interested, they can. We are ready to even if the masons are agreeing, we are ready to ship the masons to wherever they want to be taken to, or they can send their masons and get them trained with these masons. Either way, because it's actually it is hardly, it'll take 3 days or 2 days to anybody to get this, crack this. It's no big deal. I mean, now it looks like that for us. It took us a month and a half, but I know that if taken through in a certain systematic manner, this thing can be cracked in a matter of a couple of days. So these videos are there on YouTube as well as on our Insta post at kakani.soch. They're all there. All the information is there. The mortar that is used in the timbrel vault in the first one is a POP, plus regular plaster of Paris, little high grade plaster of Paris, which so you have to use very small containers initially because it settles very fast. So you use very small containers in parts, and you have to set up a whole chain process. And the first layer is done like that. The second layer, you put a coat after this, you let it rest one day. The next day, you put a half-inch layer of mortar in 1:3. After that, you start putting the next layer of tiles, which is all in mortar after that. So the first layer actually is your shuttering, which after you've done a couple of layers actually becomes part of the structure. So shuttering becomes part of the structure. So so that's how that one. In Azad, the Rohtak domes, what Azad and his team they do is they take they use 1:2.5, very rich mortar, and that's it. There is, I mean, initially I couldn't believe it. I went there. I was one of those guys jumping on that dome in Rohtak. He said, I said, "Are you sure one can stand on that?" He said, "Come jump," and he was jumping, and I was jumping along with him on that. And that was just built a day before. Regular break, and I mean, I had to believe it then. So I actually went to Roth, and that's when I was confident. So one needs to do due diligence. I think we are equally have to be very responsible, because people's lives, I mean, buildings' lives, material life. I think all this has to be equally thought through. So it is not an experiment for the sake of an experiment. I mean, if I'm talking about these kind of spans and scales, and one has done due diligence, one works through it, and but the idea is one needs to make it simple enough that it becomes easy to replicate.
Yeah.
It has to be proliferated. It has to become common. Then some system is possible. Otherwise, innovation done for the sake of innovation. I'm happy, you're happy. We clap each other on our backs and we go home and sleep well. But I think we need to think beyond.
Absolutely. I think this was one of the points that came with Sankalpa also, and he's trying to explore the MSME. He's trying to set it up as, and this is exactly the point that was discussed in the end, that in order for whole lot of these alternative technologies to get their alternative tech removed and become part of the mainstream, there are a whole lot of things that you need to do, and one is of course the research and documentation, which you have been doing the experiment, you've been trying to find the skills, and the second is that it needs to be packaged, in a way that is convincing for the people to, so that they can start accepting it on
Absolutely.
on a regular basis.
Absolutely. It has to become a viable contemporary product.
Absolutely. My question was this Timbrel vault. When I look at your sections, you used it for the floor also along with. So how successful you have been with the floor?
Very successful. We actually, you can actually just fill it up and reuse it as a floor. So on the Timbrel vault, you can just, you see, if you look at the gap, what we've done is we filled it up with waste material, of lightweight waste material, because we were also first time. So we actually contacted the ACC block companies, aerated concrete block. They have a lot of waste.
Yes.
So we picked up that waste and filled that up on the top, and then made a layer on top, and then put China mosaic on one floor. On the other floor, we put a very thin screen with lime plaster as a floor. So yeah, possible. In the Rohtak dome, we built 3 floors.
Okay.
And in fact, in the Rohtak dome, the 2 floors are Rohtak. One floor at the right at the bottom is Timbrel.
Is Timbrel, yeah. The smaller spans are, I think, the Timbrel, and then it becomes the
Span 4.7 meters by 16 meters length
16 meters.
is Timbrel.
Yeah. There's one more question from Mahroof, and he's asking about he's saying, asking, cooling is the key challenge in our times. Of course, we are in tropical climate, so cooling is what we is our objectives are when we are designing. So he's asking, what are the possibilities of scaling up and propagating the passive cooling systems? What are the challenges of scaling that needs to be addressed?
See, in a passive cooling, you see, actually, it is nothing. I mean, the only thing passive is when you actually have when you live in a cave. The only really passive. I mean, a fan is also technically, having a fan overhead is also not passive. And then putting a PDEC cooler, what we call our normal coolers that we put, is passive evaporative downdraft cooling, right? So we also, those coolers are also not passive, but they are at least reducing the use of energy, also not giving out heat on the outside. As compared to the regular air conditioning, what we all know, is creating a huge. It's basically creating a huge heat because it's transferring that heat. Because what it is telling us is that you all need to be comfortable at 25, 26, and I will take away the rest of the heat and give it to the outside, and the outside can go to hell. So that is the larger problem in this thinking, where we are very comfortable in our own little cocoons and we make ourselves, and I think our bodies are capable. We wouldn't have survived these millennia if our bodies are not capable. Take 35, even plus 45. But we don't need to live at 45. But passive can give you 35. Passive may not be able to give you 25. Now, are we ready to accept that? First thing. So I think the key is that how much are you also as a human being ready to accept?
Right.
Along with, there are challenges of pollution, there are challenges of sound, there are all kinds of urban challenges being there. So I think it's not that it's an easy answer. There isn't scaling a passive system. The best way I would say is have thick walls, reduce your outgo. In fact, in summer in Ahmedabad, most of the time, if you just keep your place closed except in the nights, it works well. But now you have issues of mosquitoes and other issues, so you end up having. But there are ways to do it. So scaling in passive, well, it depends. In apartments, I guess evaporative cooler, a regular cooler, would work well. But there are challenges. But I think it's possible.
I was looking at this reuse of buildings, the first that you started with, and there is an institute that you did in the AG Teachers Compound for
Yes.
the Ahmedabad University, and then in your own residence you incorporated this passive cooling thing, which was not there. Then you incorporated it, and you must have managed to achieve the reasonable
Oh,
comfort levels
yes.
in your homes, I'm sure.
Yes.
I'm just trying to take this argument a little further, and in almost all your projects, you have been taking care of the rainwater harvesting, taking care of that the gray water is recycled, and if it is not recycled and if it is supplied to the municipal sewer, then at least there is a filtration
Goes through us.
goes through anaerobic filters, and then it is treated and then given back to the corporation. So there is, it doesn't put a load on the existing system that is already exhausted. So all those there is a lot of consciousness that has already started happening from the resources point of view, and many corporations, many governments have already made it become part of their building bylaws. These rainwater harvesting systems they've started making mandatory. But when it comes to the comfort levels, the passive coolings, there is still not that much of an awareness. If you look at the conventional construction system of 9-inch brick wall and the RCC slabs, it produces tremendous consumption. The whole the technology is meant for air conditioning. It seems like that. Now, can it be that even the government through various these kind of promotional schemes, if you start promoting that, okay, if you incorporate these kind of passive cooling systems, and it's possible, like you've demonstrated that within an existing house also you can incorporate these things and make it functional. Do you think that can become an onus on the existing users to start adopting these things?
Uh, you see, I don't think the government has any role to play here, honestly. And all that the government can do is give you tax breaks if you do certain good things in your property tax. But as a culture, you see, I think the see the passive system can never be equated to an air conditioning system. And the air conditioning system has its own advantages, has its own space. The passive systems have their own space. I also feel that there is a potential to hybridize this, where you kind of, because there are, like in my own house, I mean, there are about 15 to 20 days where we do feel the humid heat, where a passive system does not really, beyond the point, be efficient enough. And so you live through those 15 days, and once you cross it, so what? But it's the point is the also it's a conscious notion of trying to tailor make everything for myself or for me, for the human being. I think we also need to get out of that assumption of who we see ourselves to be. How much do we need to tailor make the world around us to be so specific to our every need? And I think tolerance to that also is important. Tolerance at every level, yes. But I think to be able to tolerate, allow yourself to tolerate a few, of these things in this manner. I think I think as a society, we've probably become a little hyper in the other way.
True.
Cut ourselves off, and I think and it's getting it's only a crisis of energy, I guess, at some point, of resources of some kind that will or a certain level of consciousness. But I think as architects, we will need to, and or even as anybody, why only architects, all civil society people, all of us as a society, we just need to keep debating and talking about it. When we talk about tolerance, we also need to talk about what are we ready to tolerate to ourselves in terms of climate. We talk about religious, cultural, and other tolerances, but I think we also need to start talking of climate as tolerance now. How much am I ready to tolerate climate? Up to what point?
No, that's a very good point. I mean, you cannot ask, once install the passive cooling system and start demanding, give me now, 26-degree and 22-degree. There is definitely an educative role, and which can come by probably debates like this, not only amongst the architects but amongst at the level of the society. And I think that's a good point that you made. I would just like to end here with few questions, which sort of, because since you have been a dean at School of Faculty of Architecture, SEPT University, you have been associated with the field of academics for a very long time, and my also interest also has been with the academics. My question here is that how do you think? What role does academics has here to play in order to bring this awareness, or bring out the architects and designers who will be sensitive to these issues of the material pragmatism?
I think academics has a huge role to play, and because we are changing, we are actually training the whole younger generation in these spaces. At the same time, as much as it is about material pragmatism or of these concerns, there are the larger body of the architectural profession involves a lot of other complexities that also need training in academia, and it is through a good band of practitioners who actually continue to involve with academia. People like you, people like Sankalp, there are people who are out there who are practicing, who come back to academia, who come back and give and talk and teach. And I think it is only through that we will be successful over some time. And I think what one does see, one notices, is a lot of the pre-K-12 schools have actually, when now I'm seeing some of the students, they're already talking about water, they're already talking about climate change. They're quite aware and they are conscious, which means the K-12 systems of schools have already taken that upon themselves and have actually made them conscious. The projects that they do in schools, talking about climate, newspapers have started talking about climate. So it's a matter of time that more and more professionals who will begin to, connect onto this and not see this as an alternative, but see this as a way of designing. So what I'm trying to say is that our practice is not about doing alternative buildings and alternative technologies only. We build hospitals, we build schools, houses. But that doesn't mean that we give up on some of these concerns. It is, how do we reduce energy for a hospital? How do we make efficiencies in services? Because efficiencies in services means reduced resources use, as well as the physical capital cost, as well as in active costs. So all kinds. So I think as architects, we will have to think about resources in a much holistic manner, and yet, as I said earlier, an ability to evoke an experience that stays, and that makes the place go back to.
Yeah, I that's a good note to end here the discussion.
Thank you.
And I'm really thankful to you and your team for making wonderful presentation and sharing it with us, for agreeing to come and talk to us for this interview. And on behalf of everyone here at Aki Diaries, our team, I'm really thankful to you and your team. Thank you so much, Surya.
And I really thank you, and I really wish to also thank my team. I mean, I think I've also, as I said, not only been blessed about doing all this, it's I'm blessed because I have a great team that I work with, people who have been working with me for a long time. Engineers, I have an engineer who's been a colleague with me, Raj Ranpura. I have other colleagues and architects who work with us for a long time, and we've all enjoyed a great journey. My partner and very good critique, Jai, and other colleagues at school that I meet on and off on a regular basis, uh, and practices that are trying these things. So I think it's an ecosystem. There is I don't think anybody can work outside of that, and you have to begin to join the dots and create your ecosystem. They're all there.
Yeah.
It depends on which dots you want to connect, and that becomes your ecosystem. So I think I've been, in that sense, happy and lucky, I would say. So thank you so much for this, and hope to connect again, and we'll catch up. Thank you, everybody.
Sure.
Thank you.
Yeah, I would like to thank everyone who have joined with us for this interview. And next Saturday, we are going to talk to architect Falguni Desai from Surat. And I hope to see you guys back again next Saturday, 11 o'clock in the morning. Thank you. Thank you for joining.
Thank you. Thank you.